Hello, good morning and welcome. Today I have taken one topic about the nanocellulose, that is the bacterial nanocellulose. And first of all, cellulose is the one of the most abundant and renewable and biodegradable polymers. Cellulose, the most abundant biomass on Earth, is a linear biopolymer of beta 1 for linked deep glucose units. Uh, this is the structure of cellulose. Figure A is the morphological study of same bacterial nanocellulose. In the same study, the bacterial nanocellulose showed a heterogeneous interconnecting network. Heterogeneous interconnected network in the same study of the bacterial nanocellulose, heterogeneous interconnected network. Studied composed of randomly oriented nanocellulose. The nanocellulose are randomly oriented, interconnected, but heterogeneous network. Interconnected, heterogeneous network, and randomly oriented. Is the same study of bacterial nanocellulose. But in case of same study, this is the same study of the nanocellulose. This is the histogram, trans-tame morphology of bacterial nanocellulose, simple, and histogram length in wide distribution of the bacterial nanocellulose. And the study of tame study, the needle shape diameter was 8.54 to 24.91 nanometer in diameter, 8.54 to 24.91 nanometer. And shows crystalline character. From also the FTIR analysis, this the peak at the 1440 per cm and 1409 per cm used to determine the crystalline index, the index of cellulose sample by quantifying the crystalline fraction of cellulose sample in terms of percentage, that is the 50.09 percentage. The FTR analysis 1440 per cm and 1409 per cm, which is correspond to the CS2 bending, can be used to determine the crystallinity index of crystalline fraction of the cellulose sample in terms of percentage. It shows 50.09 percentage crystallinity. From the FTIR analysis in the range of spectra 1440 to 1409 of CS2 bending. This is the explanation of same and tame analysis. This is the XRD spectra. In the study of XRD, the diffraction angle uh, is the 16.65 and 21.68 and 22.11, which shows the crystallinity character. The TAME study shows in the TAME, the needle shaped TAME shows diameter was the 8.54 to 24.91 nanometer, but length was 65.36 to 217.3 nanometer. Diameter is 8.54 to 24.91 nanometer, and length 65.36 to 217.3 nanometer. The crystallinity structure, the XRD study analysis shows the diffraction angle 22.11 again is the crystalline character, and also from the FTR analysis, the crystallinity percentage was 50.09%. This is the explanation of the XRD. In the study of zeta potential, the zeta potential value is the minus 25.4 microvolt, indicating the stable suspension of the bacterial nanocellulose. The explanation of the zeta potential analysis. This is the FTIR of nanocellulose. The broad peak in the 3400 09 to 3352 per cm due to the weight vibration of cellulose, and near about another peak we see the 2900 per cm is the CS and CS2 vibration, and another peaks in the range of 1643 and 1654 is the NS from amide, and in the range of 1550 is the CS stitching, and 1440 CS2 stretching, and 1318 CS3 stretching. In the case of bacterial nanocellulose, 1550 is the CS stretching, 1440 is the CS2 stretching, and 1300 is the CS3 stretching. And also, the peaks we see in the range of 893 to 1105 per cm due to beta glycosidic linkage, and also 1063 the peak is the COC group. This is the explanation of the FTIR analysis, and this is the TGA and DSCA curve thermogrammetric analysis TGA and differential scanning calorimetry DSC plots of bacterial nanocellulose. In the study of TGA and DSC, we can see the disintegration temperature of bacterial nanocellulose is 315 to 4000 degrees Celsius, and 87.53 degrees Celsius is the evaporation point of bacterial nanocellulose, and 88.29 to 136.24 degrees Celsius is the loss of water, and in the temperature 700 degrees Celsius, that is the very low mass loss. In the 1700 degrees Celsius, in case of the DSC analysis, differential scanning calorimetry analysis, the 68.18 degrees Celsius is the thermal effect of dehydration and water loss from the sample. The temperature 68.18 is the thermal effect of dehydration and water loss of a sample, and similarly the temperature 289.46 is the glass transition and crystallization. In the temperature 289.46 glass transition and crystallization, and 357.19 and 415.43 degrees Celsius. In the range of 357.19 and 415.43 degrees Celsius is degradation, and 470.88 degrees Celsius is the stabilization and structural stability. 470.88 degrees Celsius stabilization and structural stability, and the temperature 338.13 is the disintegration. And from the DSC analysis, up to 200 degrees Celsius, up to 200 degrees Celsius is the thermal stability. This is the explanation of TGA and DSC. This is my reference. Thanks for watching.